With the GestureSOM patch, sonic gestures exported from the performable gestural database can be organized and clustered in a pair of parallel self-organizing maps, or SOMs. Sonic gestures from the performable gestural database are captured from musical instruments in real-time performance. Each sonic gesture has several components: gestural data, control data, the audio produced by the gesture, and various descriptors of both control and audio data. The GestureSOM makes use of the various analyses and descriptors of each sonic gesture to cluster the gestures in a pair of SOMs. A self-organizing map is a simple type of neural network that allows higher dimensional data to be organized into lower dimensional space. For example, RGB colors, a type of three-dimensional data, can be organized into a two-dimensional SOM. This is a 32 by 32 SOM, meaning it has 1,024 cells, and each cell has its own set of weights that correspond to three-dimensional RGB data. In the GestureSOM, the input data is made up of statistics calculated on sets of audio descriptors. The audio descriptor groups are fundamental frequency, signal, spectral, perceptual, and harmonic, and statistics, mean, median, standard deviation, minimum, maximum, and range are calculated for each audio descriptor in each set. For example, I can choose to use signal and spectral descriptor groups and the respective mean and standard deviation of each descriptor as input into the SOMs. The result is input data with 40 dimensions, which then get organized into the two-dimensional SOMs. GestureSOM makes use of two different parallel SOM implementations. The first is from the ml.star Max library, and the second is the ml-SOM node package. Each SOM takes the same set of parameters, and I'll set the size to be 15 by 15 to train the SOMs for 25 iterations, and set the initial neighborhood size to 5. Then I'll load up a directory of exported sonic gestures and hit the train button. Once it's been trained, you can see these two visualizations. For the color version, you can select which descriptor is mapped to each color, which allows you to see how each descriptor affects the clustering. The black and white version shows a clearer version of the clustering. Brighter areas represent cells in the SOM that are more similar to each other, while cells in darker areas are more different from one another. You can see that there's this darker line that separates this section from this section, and up here is some darker cells which represent random data, and you can see that same randomness over here. This SOM was generated with the implementation from the ml.star library. I can click here and this will bring up the node-based SOM. You can see that the different implementations result in different maps. Finally, you can graphically explore each SOM. When you click on a cell in the SOM, the gesture that is most similar to that cell's weights are loaded and can be listened to.